So let's keep going with these. So this one again is in standard form. So we're going to have to set each of those equal to y so that we can use slope-intercept form. So I'll do this first one in green. So we have minus 3x minus 9y equals 18. We want to solve for y, so add 3x to each side. So minus 9y equals 3x plus 18. And then divide by minus 9 to get y by itself. You got to do that for everything. So that would be 1. 3 over minus 9 would simplify to minus 1/3 x. And 18 over negative 9 would be minus 2. In this case, our slope actually is a fraction. So m is minus 1/3, which we can set it equal to our rise over run to help us compare it. And our y-intercept, b, is minus 2. So we can graph at minus 2 first. Let me just scroll down just a bit. So we're at minus 2 here. And then our slope, it looks like we go down 1, right 3. So our rise is -1, and our run is 3 to the right. So down 1, and then right 3 units. We get right about there. Let's connect these with a line now. See if we can extend it. And for this next one, I'll do it in orange. So again, it's in standard form, so we need to solve it for y. So I'm going to subtract 4x on each side. So 3y equals minus 4x plus 12. Now divide everything by 3. So these cancel out. You get y equals minus 4x over 3. 12 divided by 3 would be positive 4. Our slope is minus 4/3. So we're going to rise -4. So we're going to go down 4, and then our run is 3 to the right. Our y-intercept is at 0, 4, since if you plug in 0 here, you get a y value of 4. So let's graph this now at 4. And then it looks like we're going to go down 4, right 3. So let's go down 4, right 3. That's this point right here. Then we're going to go down 4 again. So right there, and then right 3. It looks to be right about here. So it looks like the lines are going to intersect there. And let me just draw in this line so we can extend it. And it'll give you at least a rough idea, but none of this is perfect since I'm doing everything by hand. And this looks to be at, this is 8, and this is at 1, 2, 3, 4, minus 4. So it looks to be at 8 minus 4. Now on the interactive grapher, you'd be able to know exactly what that is, but all we have is the ability to check it with substitution. Since both equation is equal to y, we just set them equal to each other and we can solve. And I just noticed I said 8, I actually meant 6. Since we went over down 4 over 3, down 4 over 3. So this is actually at 6, -4. So you have to be careful there. But again, this is why you would want to check your work. And the interactive grapher essentially will check it for you since it graphs it perfectly. Technically, there is another way you could check it. It's just tedious. What you can do is take your point 6 minus 4 and just plug in x and y into each of these equations. And if in both cases you get back something true, then you know that this is the coordinate point that they go through. However, once you learn the second method or the third method, the elimination method, then this is really just tedious. There are faster ways to do it. But if you actually do plug in this coordinate point to each of these, you do get back something true in both cases. So with that, you can feel confident that x does equal 6 and y does equal -4. Or at least that's where both of these lines actually go through. So let's do one final problem. And this one's a nice one because we don't have to solve it for y. We're already given y is minus 4x minus 3. And over here, y equals minus 2x plus 1. So right away, you can see the slope. The number attached to x is -2, but we'll put it over 1 so we can compare it to rise over run, the definition of slope. And our y-intercept in this case is just at +1. So b is 1. If you plug in 0, y would be 1. So it goes through the point 0, 1. And then over here with the orange one, our slope, the number attached to x would be -4. We'll put it over 1 so we can compare it to the definition of slope, the rise over the run. And our y-intercept, if you plug in x equals 0, then y would just be -3 since that term would just go away. So we'll say b is -3, or that it goes through the point 0, -3. So let's plot the orange one first. So 0, -3 right there. And then using slope, we go -4 for our rise. So that means down 4 and then right 1. So 1, 2, 3. So it looks like we're at a dash mark. So let's do the opposite. So instead of going down 4, right 1, we'll do the opposite for both. Or essentially, you'll put the negative on your run. So that means instead of going right, you want to go left. So we're still going to rise. We're going to go up 4, but now we're going to go left 1. So that'll bring us right there. And then up 4, left 1 will get us another point. And let's connect those with a straight line so that we can extend this between them all. And again, it's never going to be perfect when you're doing it by hand, but it will at least give you a very rough idea of what's going on. Now for this one, we'll plot our y-intercept at 0, 1. And our slope would be down to right 1. So go down to right 1, right there. Down to right 1, so right there. So it's not going to intersect this way. It's going to intersect up here. So we can do the opposite with this too. Make the negative go on the 1 and make our rise positive. So up to left 1 will work, or up to left 1. And it looks like it's going to cross right at that nice distinct point there. And let me just make this a little bit more to the right. And let's connect these now. And it looks like these are connecting at -2 for that and at 5 for that. So it looks like the solution is at -2, 5. And like the last video, remember, unless you want to use the substitution method where you set both of these equal to each other, which honestly is the faster way to check this, you can also just plug in these points and make sure that something comes back that's true. So if you plug in -2 here, you get 8 minus 3, which is 5. So it did work in that one. If you plug in -2 here, you get -2 times -2, which is 4, plus 1, which is also 5. So in this case, plugging in the answers was actually a fairly quick way to check it. And sometimes that is the case, especially if it's already solved for y in each of these. Then you can just plug in x and see what y simplifies to. Now, when it's in standard form, it's a little bit more tedious, or any of the other forms you might see a linear equation, plugging in the points might take a little bit longer. So that's why it's nice to have multiple methods that you can choose from depending on the situation.